Okay, let's look at graphing the polar curve r squared equals 9 cosine theta. This is a little different because it has an r squared involved, so let's take square root of both sides and see what the r values are that we get. So I can think of this as looking at r being 3 cos theta, or r being a negative 3 cos theta under the square root. And so if we want to see how the Cartesian form of this develops into the polar curve, we would have to look at these two graphs in Cartesian form and then see how the pieces develop in polar form. Knowing how to graph 3 square root of cosine theta or the other one, it's not that bad. If you know how to graph 3 cosine theta, the general shape of the cosine theta pretty much stays the same. The one thing to keep in mind is that there are angles during which cosine becomes negative, and so since I have a square root, there are pieces of the cosine looking curve that won't be there. So if I were to do a quick sketch the idea of, let's say, cosine, but I'm going to go look at my TI accurately too. Cosine looks something like that, right? So right here, cosine theta becomes negative, which means this curve that I'm looking at will have a shape similar to that. Not exactly like this, because I'm going to take square root of that cosine, but it'll look something like this, and in this region between pi over 2 and 3 pi over 2, since cosine is negative, it'll not contribute anything. And this will be very similar to this, except it's reflected about the x-axis, so I'll get a region here and here for that guy. But let's go confirm and quickly look at the TI. So I'm back in function mode on my TI because I want to see how this looks in Cartesian form. So 3 square root of cosine theta. Let's graph that guy. Oh, my window's a little off. Let me go and fix the window. Let's do a standard zoom. So notice you got all these little bumps of the cosine curve, and though the pixels don't show it very well, between there and there is really pi over 2 to 3 pi over 2, which is missing because cosine becomes negative, and when you take square root of it, you're not going to get anything contributed. If I were to plug in the negative one of it also, you will see that we get, of course, that thing reflected about the x-axis. So we get all the little, oh, I didn't put the 3, did I? Because the amplitude looks different. So insert 3. So of course I have plenty pieces on the left and the right, but I'm just going to go 0 to 2 pi and see what pieces develop and if I can have the entire polar curve picked up with that. So let's go back and do things in detail. So I'm going to go 0 to 2 pi, and I'm just going to do, let's say, the cosine curve, ignoring the square root for now. And then I know that cosine curve between pi over 2 and 3 pi over 2 becomes negative. So when I take the square root of those, they're not going to contribute anything. They'll be negative numbers. And when I take square root of these numbers, I'm going to get a curve that's arched a little bit differently, but nevertheless pieces that increase as theta increases. So those, let's say something like that, is my R1. Contributed that. And then my R2 is just the reflection of that about the x-axis. So my R2 will be those guys, and we'll just see what happens and how things develop from these 4 pieces into the polar form. Before I even do that, I'm going to go look at my TI in polar form just to see what things look like, and then we can see how your TI can sometimes be misleading. So I have, again, I repeat it, we normally need in polar form r as a function of theta, and that was r squared. So we changed it to, remember it was r squared, we couldn't input it in here, so we changed it to solve for r, and we got these 2 pieces. So I got my R1 and R2 in there. Let's graph them. Don't see anything, my window must be off. Yes, so let's go from 0 to 2 pi. And my windows from -10 to 10 for the x and y values. So it looks like, let's zoom in, looks like a bow tie. And it looks like it goes up to 1, I guess. 1 and -1 if I'm just looking at my TI. Let's go to x value of like -3 to 3, because we know those were the max and mins. So yeah, if I'm just looking at my TI, I'm seeing how the pieces develop, and it looks like I have something like a bow tie, but it's coming in at 1 here and also at -1 down there. So that's the shape. Let's go see how the pieces develop. So I have my angles labeled. It looks like the angles where all the action happens are just pi over 2 pi, 3 pi over 2 and 2 pi. Nothing is really actually going on in this region at all, so I don't expect anything between pi over 2 and 3 pi over 2 because the r values were negative there. So let's see what happens when theta goes from 0 to pi over 2, just looking at the R1 block curve. 0 to pi over 2, at 0, r was 3, and then it decreased and went down to 0. So at 0, again, the r value was 3, and as I swept through and went to pi over 2, it looks like the values decreased down to 0. So it looks like as I'm coming into pi over 2, I'm actually making the r 0. So there are all r values all the way up to pi over 3 that I can put in. So just a general shape for that piece 1, I would say at 0 it's 3, and then something like I come in and at pi over 2 it goes to 0, which already tells me that the graph I was looking at is misleading. It doesn't stop at 1. It's not. It looks like at pi over 2 on my graph it shows to be 1, but it's not 1. I know that at pi over 2 the r value goes back to 0. That's due to the pixels, the way the TI shows. If I decrease the t step, it might give me a little better representation of it, but still it'll be misleading. So we know that it does go, r does become 0 at pi over 2. So that's piece 1. And then if I stick to the block R1, I got nothing happening here from 3 pi over 2 to 2 pi. It looks like my r goes from 0 back up to 3. Same way symmetrically that I did the other piece, because again, keep in mind this has polar axis symmetry. If I replace theta with negative theta, I'm going to get the exact same equation back. So here I'm at 3 pi over 2 when the r value was 0, and I'm going to sweep from 3 pi over 2 all the way back to 2 pi, and as I sweep to 2 pi, the r value increases and goes to 3, something like that. So that's my second piece. It got developed there. So R1 pieces give me stuff on the right side. Again, due to polar axis symmetry, replacing theta with negative theta, I get the exact same equation back. I already know what's going to happen here. I know that the other piece will be here, but for practice purposes, let's go look at the red pieces and see what they do. As I go from 0 to pi over 2, R2, the red piece, so let's call this R1 and R2 depending on the color what we get. We go from -3 to 0. So focusing on the red piece, from angle 0 to pi over 2. So from 0, again, I'm back at 0 to pi over 2. If I'm sweeping 0 to pi over 2 here, all the action is happening across from it over here because my r values are negative. So I'm really sweeping here, 0 to pi over 2, but r's are being developed back here across, vertically across from it. So I have -3 for the 0 angle, which was right here, and so at the 0 angle I'm at -3, so back here I have an r value of -3, and I'm sweeping, and that -3 increases back to 0. So I get a piece here that would be symmetric to that. Mine looks a little bit off. So that's piece 3 and piece 3 here. And last, f 3 pi over 2 r is 0, and then it goes down to -3 when we get back to 2 pi. So f 3 pi over 2 r is 0. So now I'm sweeping from 3 pi over 2 back to 2 pi. And since r's are negative, all the action is really happening over here. And at 3 pi over 2, I'm at 0. But when I sweep and I get back to 2 pi, I'm back at -3 for my r value of 2 pi. So something like that happens there. That's piece 4, and this is piece 4. So again, this is symmetric. My graph doesn't look very good. Actually, it looks like it has pi over 2 vertical line symmetry, and polar axis symmetry, and pole symmetry, because any of those two imply the third symmetry anyway. So let's go back and look at the TI and point out that this is a little bit misleading. By analyzing it piece by piece, we saw that it actually does go into the pole at pi over 2 angles, or that the theta pi over 2, it goes into the pole. It actually does have the point 0, 0 on it.